25 years ago, Microsoft launched Windows 95. The comet Hale-Bopp was discovered for the very first time, and the UN held the first climate conference. There was also an important event in the automation industry. Michael, can you tell us a bit more about that?
From our point of view, and also I think from the automation industry's point of view, the important event was the first presentation of the bus terminal at the Hanover Fair in 1995. The bus terminal at this time was a kind of revolution. It combined the idea of field bus technology with the concept of a passive terminal block. Field bus technology at that time was not new. There were already field bus modules available, but they were quite big, maybe 12 centimeters wide, containing 16 or 32 channels. And if you need additional channels, you have to install a block of the same size. You have to wire the field bus cable. You have to wire the power supply. And so not very scalable and not very flexible. The idea of the bus terminal was to have it much more scalable and much more compact. So in 12 millimeter width, and just by plugging the system together, you are automatically connecting the communication, the power supply for the field side, but also for the system side. And so you get a very compact and flexible system for connecting signals locally or remote via field bus to a PLC.
Michael, I think you brought us some numbers because since 2006, or since 1995 actually, there has been a lot of developments going on around our bus terminals.
Yes, that's true. We have done a lot of developments, and I brought you some figures from the last 14 years. So if we look into the details, then, for example, in 2006, we had already more than 700 different terminals in our price list available. And over the last 14 years, this number rose to close to 1,300 different terminals. And those developments took place in all different signal ranges. So in digital inputs and outputs, in analog modules, communication modules, position and feedback systems, motions and bus couplers. So that means there's innovation regarding signals, there are new signals implemented, there is higher density implemented into the same housing, and all this is possible because we have a 100% in-house development of all our I/O modules. We have a very high depth in our production, and most important, we have a very close contact to our customers. So we can react to our customers' needs and develop latest technology that is needed for their machines and applications.
So it's fair to say that we have the right bus terminal for the right signal with that huge amount of variance. Now, let's get a bit nostalgic. Let's look back in time and let's have a look at the very first bus terminal. I think you brought a picture.
Yes, we have one picture here of the very first bus terminal, like it was presented in 1995. And the interesting thing is that even more than 99% of those terminals presented 25 years ago are still available for our customers. That means we do not only have innovations every year, we also keep our products available as long as possible. That gives security to our customers that we do not trigger redesign efforts because of discontinuing products. They can trust us, they can rebuild old machine concepts, and spare parts are also available over a very long time.
Since 1995, we've actually developed further form factors to react to the market's demand. What form factors are that?
There are a lot of form factors, but let's start with the core development of the bus terminal. The bus terminal, like it was presented in 1995, in the 12 millimeter wide housing, which contains from 1 up to 16 channels. And over the last 25 years, we could even increase the channel density in those terminals a lot. When we launched the system in 1995, there were just up to 4 channels in one 12 millimeter wide terminal. In between, we could increase it to 8 channels, and today we are able to put up to 16 channels in one 12 millimeter wide housing. And of course, On the bus coupler side, we also have the possibility to connect the system to all market-relevant communication systems.
Another important Beckhoff development happened in 2003. It was the launch of EtherCAT. What impact did EtherCAT actually have on the bus terminal?
EtherCAT is a very basic component in our terminals because the technology of EtherCAT itself, with its high bandwidth of 100 megabit and its perfect synchronization due to the distributed clocks, which enable us to achieve a precision of less than 1 microsecond jitter, was implemented also into the EtherCAT terminals. And this technology platform of high speed into each and every terminal and a perfect synchronization enables us to implement complete new functionalities into our I/O system. For example, we can sample analog signals at a very high sampling rate and can carry those data to further processing to the PLC. And due to the perfect synchronization, we can also run server access in our I/O system because the synchronization is possible via the EtherCAT bus system. So this technology platform is the base for a lot of our new developments and also for the future.
Okay. So that enabled actually a lot of new possibilities. Now at Beckhoff, we do have a lot of machine builders as customers. And for these machine builders, it's extremely important that they have the possibility to quickly manufacture their machines. So, Michael, what did we actually do to satisfy what these kind of customers are looking for?
Yeah, the bus terminal itself, the concept of making the connections to the sensors and actuators by individual wiring in the control cabinet, we think that's the right solution for 90% of all our customers. But we also have customers that build machines at a very high volume. And for those manufacturers, it's very beneficial to use our concept of the bus terminal for the printed circuit board, or like we call them, the EtherCAT plug-in modules. Those modules contain the same technology from electronic and software side and are also networked via EtherCAT, but they have one connector where power supply, signals and EtherCAT communication is connected at the back of the module and can be plugged onto a PCB. And those PCB is responsible for the signal distribution for application-specific connectors, where you can directly connect machine modules via a cable harness. That means this principle, doing the signal distribution on a PCB, enables our customers to manufacture those PCB at high volume production, automated, and they can just plug modules and plug cable harnesses. So in fact, they wire a machine like you wire a car. You just have control units, cable harnesses, plug it together, which is very quick, but it's also a very little risk of doing something wrong. So you minimize the risk of failure, which is very important for customers today who have different manufacturing sites in different countries, for example.
So quality goes up and the manufacturing time goes down. Now, sometimes there is simply no cabinet and the I/Os needed to be mounted straight in the field, and as we all know, the industrial environment is normally a quite harsh environment. So what did we do there?
Yeah, for those requirements, we also use the same technology and just repack them into IP67 proof housings. Our standard plastic housing for industrial use, also networked with EtherCAT, the stainless steel housing for food industry and pharmaceutical industry, and for very rough environments, we even have our zinc die-cast housing, which is giving a good shielding. It's also very robust from the mechanical point of view.
Machines represent a safety hazard that needs to be addressed, obviously, because we don't want to harm any operators. And there are a lot of safety sensors and actuators out in the field. How can we actually support our customers to connect these?
Yeah, of course. The task of a modern automation system is also to address the safety requirements of a machine. That means we have to have an interface to connect safe inputs like emergency stops, monitoring of doors and fences, light curtains, but also to switch safety-relevant actuators or even to monitor safety-relevant temperatures and analog signals. And all these safety technology is implemented by hardware and by software into the Beckhoff system. And looking to the I/Os, we have safety modules in all our systems. So as a terminal, as well as IP67 modules, or also the plug-in modules for the printed circuit board. They also contain the logic functionality, also the safety PLC, like it is called. And so safety is an integrated element of our automation system.
Okay. But I think, Michael, that's not all. We have a lot of other kind of terminals. Can you give us an overview of those?
The other technologies which we brought step by step into our system is, for example, the explosion-proof terminals. So these intrinsically safe modules limit the energy that goes to sensors and actuators that are installed in areas where there is a high risk of explosive atmosphere. And by integrating such technology into the standard automation system, you don't need additional components to be installed between the automation system and the explosive boot area. That means no additional components and ease of the system, and the performance of EtherCAT is also available in process automation applications, which gives benefits to a lot of processes.
With this lineup, the process industry is covered. Michael, what other areas have we actually integrated into our bus terminals and EtherCAT terminals?
In the recent years, we also have addressed the needs of measurement applications. Classically, measurement technology is manufactured by different companies. It's separated systems. And if you have, for example, a test stand in the automotive industry, you have a system responsible for the automation of the test stand and a second system for really measuring the values. We have now developed high precise, high-speed modules with very reliable measurement data to be integrated into the same system. So the advantage is quite obvious. You don't need to install two systems. You don't have to interface these two systems. You have the high-precision measurement technology with the application-specific connectors, like you see here in the picture, also with the connection technology required by those applications, with the standard push-in technology or the LEMO connector for test stands, or for high-frequency signals, the BNC connector. So as a result, we don't have two different vendors anymore. We don't have two different systems anymore. All is integrated into one system now.
Now, when we talk about automation industry and machines, they are always moving parts. Now, what have we done to integrate drives technologies and bus terminals?
Integrated drive technology in our I/O system, we have already since more than 10 years. It started with stepper motor terminals integrated into our system, and today we not just have stepper motors, we also have DC motors, brushless DC motors, and a complete range of low voltage servo drives. And this technology is so powerful that today we have an electrical output power close to 1000 watt, including functionalities like safety and also safe limited speed, and also the path control is integrated. That means you have the choice if you run the closed loop control on your PLC, like for interpolated motion and CNC and NC applications, or if you would just like to use the terminal to change the formats on a machine, and you just give the command to the machine, change format from position 1 to position 2, and the terminal itself is controlling the movement with pre-configured speed changes.
We have fully integrated a servo motion amplifier, including safety, into our I/O lineup. Michael, there are a lot of protocols beside EtherCAT in the automation market. What impact did that have on our I/O lineup?
Beckhoff is a company of open interfaces. This is true for the software side, for the PC side, but it's true as well for the I/O side. That means for other field bus systems, or let's call it intelligent communication interface. because not all of them that you see here are really field bus systems. We have implemented them as master or slave terminals, just communication interfaces to nearly every intelligent communication system which has some market relevance. So that means the possibility for our customers, if they got a sensor or they have an existing machine and they like to connect the new machine or the data collection system, it's more than easy because for all those interfaces you see behind me, we have the right interface terminal available.
So we support actually a lot of protocols, and thanks to that, we are able, I assume, to serve a lot of applications, a lot of brownfield applications as well, while connecting to third-party networks.
That's true. And we can also very smart network to existing to older machines, because no customer is buying all the machines at the same time. There's always an installed base, and to make interfaces to the installed base is always important. And there we support our customers by providing also those interfaces in our most modern systems.
Beckhoff is also a well-known company for their IPCs and embedded PCs. Now, how compatible are our I/O lineup with the embedded PCs, for example?
As a system supplier, it's of course very important for us to have the interface between our I/Os to our control units like the embedded PCs of the CX series. And those possibilities are, once you can directly connect it to the IPC, like you see it here, or of course you can connect it via EtherCAT. And as scalable as our I/Os are regarding performance and signal density, we have the same scalability regarding the CPU performance on our CX controllers. So this perfect scalable system from the compact controller to the high-performance PLC.
That's an advantage for the spare parts stocking strategy, because now you can choose if you want to use the slice or the terminal itself for the PLC or the IPC, the embedded PC in this case, or if you just want to use it for the remote station where you just read your I/Os.
That's true. We don't have separate form factors for local I/O and distributed I/O, but as well it is an advantage that we have this scalability also on the controller side. If you find out in your development phase that your controller is running out of performance, there's always a higher performance CX controller available. So that means there's not just one solution for your controller, it's a real scalable family, and you can always pick the controller of choice that is suitable for your application's requirement.
So it's truly a universal I/O lineup. Michael, if you would have to qualify our bus terminals and EtherCAT terminals in one sentence, what would it be?
In one sentence, one of the fundamental components in automation.